Welcome to the 2019 edition of the Database Systems course. My name is Srinivasa Kumar. So, this course is split into several modules, like about 8 modules are there. There is an introduction, and then the main module is about the relational model, and we also have what is called the entity relationship model module, and then we have tuple relational calculus module and SQL, the database language standard, and then we have a module on file systems and physical representation of databases. And we will be spending some time on designing databases by studying what are called normal forms for database designs. So, that will be a separate module. And then finally, towards the end we will discuss the techniques of query optimization, and then the last module will be transaction processing and error recovery. So, this is how the course is split into several modules. So, in a module there will be several lectures, and the we may not be able to, we will try to keep the lectures such that we do not start off a new module in the middle of a lecture. Okay. So, let us go ahead with this course. It is a very interesting and fundamental course for computer science curriculum. So, the course is largely about relational databases. So, let us begin by asking what exactly is a database. What exactly is a database? Now, database is a collection of related pieces of data that represent or capture the information about some real world enterprise or part of the enterprise. So, sometimes an enterprise might be so big that it might actually require multiple databases to capture its complete information. So, it is related pieces of data that I think is easy to understand, because supposing we are talking about, as I said, supposing we are talking about a say university database, suddenly we do not find weather data in that, right. So, it has to be all related. Now, the data is collected and maintained to serve some specific data management needs of that particular enterprise. So, there is a purpose behind building the database, and the day-to-day activities of the enterprise are actually supported by the database, and they will be continuously updating the database. Database is a collection of information. So, as the enterprise works and changes happen in the enterprise, all those changes will get reflected in the database, and they continually update the database. Now, let us take an example, say university database. So, the information that we would like to collect in this context is data about students, faculty who are teaching the students, the various courses that are available for study. A course is a subject, right. And then research laboratories, their information about them, and the process and the enrollment or registration of students in various courses. All this information would like to keep track of. So, let us say our database reflects the state of the affairs of the academic aspects of the university. That means, we will there are some, let us say there are several things that we need to keep track of in a university, but this particular database takes care of only the academic aspects of the students. So, the purpose is, as I was just now mentioning, to keep an accurate track of the academic activities of the university. So, this is an example situation where we will require to build a database and then operate the database and then keep track of the various activities related to the academics of the university. Now, let us first distinguish between two things, a database and a database management system. Okay. A database is, as I was just now mentioning, collection of related pieces of data. Now, this collection of related pieces of data could actually be maintained even in physical ledgers, books, right. One could maintain that, but then we are talking about how do we computerize this whole thing and then maintain this on computer systems, and that is where a database management system will come into picture. Okay. A database management system is a complex and general purpose software system. It is a software, pretty complex software at that, which will help us create large disk resident databases. Large disk resident. Disk resident is important here because disks are the medium which gives us the ability to store data for a long period, and of course, disks do fail. So, we will have to keep track of, we will have to handle that issue separately, we will also discuss that. But secondary storage is the mainstay of databases, because the primary storage of memory is volatile, and as applications close, the information stored in volatile memory will vanish, and whereas for databases the information has to be maintained for a long period, and we need disk resident databases. So, DBMS helps us in creating these large disk resident databases, and it also helps us in posing data retrieval queries in a standard manner. Okay. So, once we have a database, we would like to retrieve information from the database and make use of that information for various purposes, right. So, has this student in his third semester done this particular course and obtained a grade or not? We would like to figure all that out. So, how do we get the information is there in the database, and we need to pose a query to the database and get back the answer from the database. Now, DBMS and in general the relational database theory enables the process of posing this particular query in a particular standardized manner, and you are all probably aware of that standard, which is this SQL standard. SQL is not only just language, it is in fact a internationally recognized standard of how to pose queries. Okay. So, the database management system supports this standard, and it is a system's work to kind of ensure that the query results are retrieved efficiently. That means, in as short time as possible, we would like to get the results. So, this will depend on how much data is actually being stored in the database, because if a huge amount of data is actually stored in the database, then retrieving a particular piece of data might in fact take a lot of time. We do not. So, it is in this context that efficiency of retrieval of data comes into the picture. So, the database management system strives to, always tries to provide efficiency while running queries, efficient solution. Right. Then another important aspect is the concurrent use of the system by a large number of people in a consistent manner. Okay. Now, a database system is meant to be not just to be used by one person, it is in fact used to be used by a huge number of people, and it turns out that it is much more efficient for us to run these requests from the end users about for information from the database in a concurrent manner. That means, the end users will get an impression that the database is actually answering only his or her question, but it is actually concurrently handling several hundreds of people. It is inefficient to make the database server answer one question at a time, because we will later on see why it is so. But and so we would like to make the system answer queries, answer end users questions in a concurrent manner, and while that is happening, maintaining consistency of the data is an important aspect. Now, what exactly is a consistency requirement will depend on the actual application or actual database, right. So, for example, to give an instance of this kind of thing, in a railway reservation system, a major consistency requirement is that at no point of time a seat is allocated to two people. Right. A seat between one point A to point B on a particular train should be allotted to exactly one person, it should not be allotted to two persons, right. Now, imagine this situation in the context of these seat requests coming from concurrent users, hundreds of users at a time, and maybe several of them are asking for seats between point A and point B, and in that context we should ensure that the system never allocates a particular seat to two different individuals. So, like that, consistency requirements will change from database to database domain to another database to database, and those things have to be kept in mind while we are concurrently running the large amount of these requests, large number of these requests. Now, another important aspect of this databases is that it is the guaranteed availability of the data, irrespective of system failures. Now, what kind of system failures are we talking about? System failures are several kinds of system failures are possible. One of these, let us look at them, let us pause a little while and then see what are the system failures that we have to handle. First thing is the storage medium can fail. The disks on which we are storing information may fail. You have all probably keep backup of your data on the laptop, because the laptop disk can fail, right. So, disks do have this failure probabilities, and disks can fail. So, but a database management system which is handling the data of a large enterprise, has to be careful, and it cannot say that my disk has failed and so I lost your data, right. That is never that should never be allowed. So, the data should be permanently guaranteed that it is going to be available irrespective of system failures. So, we should take appropriate measures in the DBMS database management system such that even if disk fails occur, the data will continue to be available. Now, enterprises based on the kind of database management system we are talking about and the various components in it, we have to, there are several measures that are taken in order to handle this issue. Like for example, you sometimes replicate the entire data in a database in a geographically different location, so that even if there is a catastrophic failure like a fire or storm or something like that, and a database, physical database server is damaged beyond repair, the data is still available in a geographically different location. So, we have to take this kind of measures in order to ensure that data is. Now, those failures are what are called catastrophic kind of failures. They are rare in occurrence, but then more often what happens is that these processes that are running on the database might encounter some errors and might crash, programs might crash. So, and if the program crashes, if a particular application, if a particular process that is doing certain changes for some reason crashes, then if it has changed this database and then could not complete its work and crashed, then we should also ensure that its changes are not really reflected in the database, because it might have done some partial work on the database, and such things is not such thing might actually affect the consistency of the data. So, irrespective of system failures are of several kinds, we will in fact discuss this topic in much detail when we go to transaction processing and error recovery module of the course. Now, one question that you might ask is that why do we need a special purpose software, this DBMS software? Why can't we actually, we are all know C, the language C or C++, as the case may be, which are pretty powerful, so they are capable of handling files, and then after all information is all nothing but structures or records, and then we can create files of records, files of records, and then store this information on individual files, and we can then write programs to manage these files of records and then provide this kind of capabilities all by ourselves. A programmer who is capable of handling files and the operating system provides file system, and so we should be able to write programs that will you have probably tried that out in a data structures kind of course, where you open files and then keep track of the structures and search through records and then retrieve records and all that. So, why do we go for this special purpose software? Why can't we do it ourselves? Now, first thing is, if you go for files of records, maintaining consistency becomes difficult. Okay, so let me explain this a little bit. Let us imagine two kinds of data management requirements. Let us say one application wants to keep track of the students, their courses and grades. Another application likes to keep track of the students information about the health records of students. Let us say the institute hospital requires that kind of an application. Now, certain basic information about student is replicated in both places, like the student's name, contact number, addresses, and such details are obviously to be replicated in both places. So, that leads to a lot of redundancy of data. Data will be stored in two different places in a redundant manner. But nowadays redundancy of data is not a big issue. I mean, we have large disk space disks, and we can maintain them. It is not a big deal actually to have a lot of information stored. Your the smartphones have 64 or 128 GB of space nowadays, right. So, this space alone is not an issue, but what is an issue is if you store a piece of data in two different places, if a change occurs, then in order to keep this information consistent, you have to necessarily change it in all the places where it is stored, right. Otherwise, there is inconsistency in data, right. So, according to that particular set of records, his phone number is this, according to this another phone number is there, I mean, which is the actual phone number, I mean, you do not know, right. So, it all has to be updated in all the places, and updating and maintaining this, if you write your own independent programs, becomes really difficult, because this requires communication between the operators of those specific programs, and all kinds of problems are possible here. Now, another thing is that these record structures that we create in order to keep track of information will have to be hard coded into the programs, right. You have when you write a C program or a Java program, you will first declare variables, right. So, the structure, before you can create a file of these structures, this structure has to be defined. You have to give a declaration of the structure, and then create variables of that particular type, and then create a file of that particular kind of records, etc., right. So, these once you hard code them into these programs, any change, any slight modifications in these structures will lead to recompiling your software. You have to change the definitions, and then recompile and create a new executable, and then run the program again. So, the structural modifications become hard to perform, whereas we will see later on how DBMS approaches this issue. Now, most important thing is that we, in the last slide also we discussed about queries. Now, if you write your own programs, then how do you handle queries? How do you handle queries? How do you anticipate what are all the kinds of queries that come each week? Because for each of these queries, you have to write a special purpose program, because you have the set of records with you, and so if you have to process a query, then you have to write a special program which will take the requirement of that query and then search through the records and then give out the answer. That is the only way you can handle queries. But then how many different queries are can you write programs for? I mean, there are different kinds of queries. So, it's very difficult to kind of anticipate all such queries and then write programs for all of them and then keep them ready, so that when the end user says that okay, I want this information, you can write okay, go and run the program 10, it will give you an answer. So, it is impossible to do that. So, creating any database like system by writing our own set of programs is a very requires a huge amount of effort, and it is almost kind of impossible to achieve the requirements of a database without going for a database management system general purpose software. Okay. So, the DBMS approach of course, another thing is this managing the concurrent accesses and then failure recovering from failures. This is also becomes a programmer's responsibility, which is again a concurrent accesses. Managing concurrent accesses is a very difficult task, because you are almost like doing a job of an operating system in that thing. So because of all these reasons, we will actually not attempt to write our own set of programs in order to handle the requirements of a database thing. So the DBMS approach to this entire issue of creating and managing databases is very interesting. First thing is, it does the separation of data and metadata. So the metadata, which is this structure information, that means all those various components that go into structure definitions, these are maintained separately in what is called a catalog of the system. In a catalog, we will separately maintain the record types and separate them from the actual programs that handle those records. Okay. So this gives us flexibility for changing metadata. So this aspect is also what is called program data independence. So now how can you how does this help the DBMS? The software that the program that you will write will now become independent of the structure. What it does first is to, okay, if you have to handle a certain kind of information, it will first go and check in the catalog as to how that information is actually stored in a file, okay, get that information and then start operating that particular file according to that metadata that has been supplied about that particular file. And this also happens internally. So programs become in some sense independent of the data that they are handling. Okay. So if there is any structure modification that has to be done, it can be done at the catalog level by a separate program, and then those programs that are handling this information can again read this modified catalog information and then go about handling the actual data records. Okay. So that way we get what is called program data independence. Because of this, the DBMS becomes general purpose because it will a DBMS typically can be used for creating different databases. One database for say hospital records, one database for staff accounts and salaries in an institute, one record for one database for the academic records of students, etc. Okay. So but one DBMS system will be able to handle all these 3 or 4 different databases. Okay. So for each of these databases there is a separate catalog information, and so the DBMS first opens the catalog of how the information about that database is actually stored, and then goes about manipulating the actual information in the database. That is how it achieves general purpose ability. Now SQL is a standard. So SQL has resulted after this relational database theory has been adopted for constructing databases, and SQL is a worldwide standard, and as long as you implement all the SQL semantics, then we can actually handle any kind of query. So, query formulation becomes easy because this language standard SQL will help us express our data requirement queries, and all the DBMS has to do is to basically implement the structures of implement the constructs of the SQL. Okay. And so, it kind of handles all kinds of queries, and SQL is internally is based on what is called tuple relational calculus, and also we will be studying what is called relational algebra. All of these things are there inside the box, so to say, and once you establish that these languages are capable of handling all kinds of capable of representing all kinds of queries, all that the DBMS has to do is to implement the language. Once the language is implemented or the standard is implemented, then all this ad hoc query formulation becomes easy. So, that is why that is the major advantage of going for a DBMS software. Now, overall system development of a particular database, take for example, let us take this the academic aspects of students. So, it requires us to sit down with the academic section of the institute or the university, and then find out their requirements as to what are the various things that they would like to keep track of, and then come up with a logical level design. And we can actually, because of this DBMS availability of DBMS, we can actually concentrate on the logical level of the design, and then we can kind of implement it on top of this with the help of this DBMS. So, all these components to kind of organize the data storage, the processing of queries, the management of concurrent users, all this is automatically taken care by the DBMS. So, all that the designers have to focus is now on the logical design of the database itself. What kind of information is represented, and what kind of standard queries are required to be run on a day-to-day basis, etc. All these things, if you decide, then we are all set to kind of set up a database. So, actually some of these things are unless you really think about it, you may not realize it, because you might be actually using some web based tools that will set up the databases for you and things like that right now. So, unless you really think a little while, you may not realize as how life was without a database management system, because now people take it for granted that if you have to set up a database, you use a database management system, and popular database management systems are Oracle, is DB2, IBM's DB2, and Microsoft's SQL Server, and so many other database management systems are available. Okay. Any questions in whatever we have been talking about? Okay. Now, let me bring in a new one interesting concept, the concept of a data model, A data model is a collection of conceptual tools to describe the database at a certain level of abstraction, Computer science is a science of abstractions. We create abstractions and make use of them, right. So, I will actually tell you as to why there is a need for describing the database at various levels of abstraction. But first thing is to understand that there is a collection of these conceptual tools that will help us in describing the database in a certain at a certain level of abstraction. We will talk about data models in detail now. Now, various kinds of data models are possible. One of them is conceptual level data model. A conceptual level data model is in some sense a very high level description. It enables a very high level description of the database, and it is very useful when we are trying to understand the requirements of the database, when we are trying to understand the requirements of the database. So, when we go and as a team of database designers, when you go to the academic section and then talk to them as to find out how what kind of information you would like to keep track of, etc., it is this model that we will try to use to gather the requirements. We will go into in fact, there is a whole module on one of the popular conceptual data models, which is this entity relationships model. We will talk about it in the next module. Then there is this representational data model. This describes the database at a logical representation level without really giving much details about the physical representation. Ultimately, all data is physically represented using files of records. Okay. Physical representation at the lowest level is in the form of records, files, okay, and certain external data structures. You have studied data structures which are in memory data structures. In this course, we will look at disk resident data structures. So, okay. So, with a collection of files, records, disk resident data structures, we will actually physically represent the database, but at the in a representational data model, we will not really bother about, we will hide all these details, we will hide these details and then only talk about a logical representation, how logically how data is represented at in a logical manner. That is what we will describe. This helps us in focusing on the design. If the design is not proper, then we might actually get into a lot of problems, and so we would like to focus on the design of the database, and we can do that with the help of this representational data model. Then the physical data model is the one that actually describes all the full details of the various record formats and then the file structures, what kinds of files are there and what kinds of external data structures are there, etc., and how are they related to each other. All that information is to be represented, and that will happen at the physical data model level. Okay. So, now we will take one by one. I will give you a little bit more detail about the conceptual data model and the representational data model in the next few slides. Any questions? Okay. One of the choices at the conceptual level data models is what is called an entity relationship model. What it does is to provide concepts of what are called entities, relationships and attributes. So, these are a little bit general kind of concepts which we can explain to non-computer science people, non-technical people. We can quickly explain these concepts to them and then sit with them, discuss the database data, database description, what kind of a data you want, what are the various entities to be kept track of, what are various things to be, all that we can discuss. In terms of these concepts, we will engage in a discussion and then gather requirements for the database. For example, if you take the same university database context, the entities, the major things that the database has to deal with could be a student, faculty member, course, departments, etc. These are the various things that it has to handle. And then the relationships, that means associations between these entities. For example, is the enrollment relationship between student and course. Students enroll into courses. The employment relationship between faculty and the department. Each faculty is employed in a particular department, etc. So, these are the kinds of example associations or relationships. And then various attributes. There are various attributes like the names, roll numbers, specific roll numbers given to students to identify one student from the other, the addresses, the address of the student, etc. This could be the some of the attributes of the student entity that we would like to capture. So, we will give more details about this entity relationship model in a separate module that we will take up just after the introduction. Okay. So, at this stage the takeaway point is that there are this conceptual bag of tools using which we will describe the database at a very high level and sometimes at logical level and at sometimes at the most detailed level. So, we need tools to talk about these things with the descriptions of the database itself, and those things are what are called data models. Okay. So, I will in the next class I will talk about the remaining kind of data models. We will stop today with this. Okay. Thank you.